Okay, welcome to chapter 3.5, equations of parallel and perpendicular lines. The essential question for this chapter section is, how can you write an equation of a line that is parallel or perpendicular to a given line and passes through a given point? What you will learn is how to use slope to partition directed line segments, identify parallel and perpendicular lines, write equations of parallel and perpendicular lines, and use the slope to find the distance from a point to a line. So partitioning a directed line segment, a directed line segment AB is a segment that represents moving from point A to point B. The following example shows how to use slope to find the point on a directed line segment that partitions the segment in a given ratio. So that's example 1. Okay, example 1 is partitioning a directed line segment. So partitioning means to do just that, take it and take parts, partition. So if you have ever seen a room and the wall unfolds and folds up and creates 2 rooms from one, that is called a partition. You partition the room into 2 rooms. So this is what this is. Find the coordinates of point P along the directed line segment AB. So P is along AB somewhere. So P might be here, or P might be here, or P might be here. Somewhere along this line, we have the point P. I'll move it over here for now because we don't know where it goes until we do some work. So it says it's along the line segment AB so that the ratio of P, so if P were here, the distance from A to P is to PB is 3 to 2. So AP from A to P, and then from P on to B takes us to the other end of B. So what we want to do is add 3 and 2 and get 5. And that is going to be our denominator for both of those fractions. Because 3/5 plus 2/5 equals 5/5, which equals the whole thing. Okay, so if you put P, let me explain that. If I drew P as 3 units and from P to the other end B, so AP is 3 and PB is 2, the total distance is 5, and the red segment is 3/5 of the whole thing, and the green one is 2/5 of the whole thing. Hopefully that makes sense to you. And so that's what we have to do. And the next thing we do is we have to find the slope of line segment AB. So slope is M equals y2 minus y1 divided by x2 minus x1. And if this was point A is the first point, that'd be x1 and y1. And if B is the second point, this would be x2, and this would be y2. So when I substitute in my givens into my equation, y2 is 8 minus y1, which is 2, over x2, 6, minus x1, 3. Well, 8 minus 2 is 6. 6 minus 3 is 3. Okay, so leave it as that. Do not reduce it. This is our slope, or our rate of change. So that means we rise 6 and run 3, and we're on the other end. All right. So now that we have these ratios, we want to take that percentage of each piece. So we're going to use the run as my x's. So the change in x will be how far we go. So I'm going to focus on let me change colors. I don't want red. I'm going to focus on my run. Remember that this means rise, over, run. Okay, change in y over change in x is another way to say it. it's rise over run. So how much did this rise? It rose 1, 2, 3, 4, 5, 6, and it ran 1, 2, 3, and we're back on the line. That's what rise over run means. So our run is the denominator. Our run was the x's. So our run is the denominator 3. And we want to multiply that by our pieces here, our 3/5 by that 3. So our run is 3. So I'm going to multiply that run of 3, the bottom, by 3/5. Okay, so we're going to multiply that by 3 over 5. And when I do that, I get 9/5. And that equals 5 goes into 9 once with a remainder of 4, and 5 goes into 40 8 times. So my run distance will now not be 3, it'll be 3/5 of 3, which is 1.8. So if I start here, it means to go over 1.8, which is not quite 2. So I'd say about right there. That's how far I would go to on my run. So then I'm going to do rise. My rise is equal to the numerator, which is our y's, which is 6. So I'm going to take my 6 and I'm going to multiply that by our ratio of 3/5, 3 to 2, 3/5. I'm just using this first one, by the way. And I'm going to get 18 over 5 when I multiply that, because that's over 1, right? And same with this 3, that's over 1. So then you ask yourself, how many times does 5 go into 18? Well, 5 times 3 is 15 with a remainder of 3. So if I make it a decimal, it's 0.15, remainder of 3. So 5 goes into 36 times. So 18 divided by 5 is 3.6. That means I go up 1, 2, 3.6, and I should be on the line. And that is where my P will end up. I'm going to put that right there. So what that means now is, it went behind, so let me put it on top there. What that means is this distance is 3/5 of the whole distance, and this piece is 2/5. Okay, so the ratio is 3 to 2. So what point was that? Well, the point was we were at 2. No, this is 3. I'm sorry. We were at 3. We went from 3 over 1.8 more. Well, that's 4.8. And then we aren't going up all the way to 6. We're only going up 3.6 from 2, which is 5.6. So the value at P is over 4.8 and up 5.6. So this is the point location of P, 4.8, 5.6. Okay, so after seeing this, you should be able to do problem numbers 3, 4, and 6. Okay, identifying parallel and perpendicular lines in the coordinate plane, the x-axis and the y-axis are perpendicular. Horizontal lines are parallel to the x-axis, and vertical lines are parallel to the y-axis. So we have a couple of theorems here. Theorem 313. What are you doing? Stay there. Okay, theorem 313, slope of parallel lines. In a coordinate plane, so since we have coordinates here, this is a coordinate plane. These lines are passing through coordinate 1 and 4. Two distinct non-vertical lines. They are not vertical. The y-axis is vertical. So these are non-vertical lines. Are parallel if and only if they have the same slope. Any two vertical lines are parallel. So if I drew a vertical line, let me do that. So if I choose another line, let's make it green, and I drew it right here, and it's vertical, like so, no matter where I draw that, I could draw it over here. If it is vertical, then it is parallel to another vertical line, which is the y-axis, or the y-intercept. Yeah, y-axis. I was right the first time. So this is parallel to the y-axis if it's vertical. Okay, that's what that was saying. Let me get rid of this stuff. Let me get rid of this. Okie dokie. So any two vertical lines are parallel. So this blue line and red line have the same slope, then they are parallel. That proof is on page 439 and page 444, exercise 41. Long ways off from here. All right. Theorem 3.14, slope of perpendicular lines. In the coordinate plane, which we're in again, two non-vertical lines, so this blue line is not parallel to the y-axis. This red line is not vertical. It's not parallel to the y-axis. They're both non-vertical lines. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So in other words, if I looked at this diagram, I would say that this slope looked like it was about -2. So if the slope of the blue one, the slope of line 1 was -2, and the slope of this line would then have to be +1/2, because -2 times a +1/2 equals -1. So down here it says reading, if the product of two numbers is -1, then the numbers are called negative reciprocals. So you can think of -2/1 as a fraction. -2 is a whole number, but anything divided by 1 is still the same. So if I take the negative of a negative, I get a positive, and I take the reciprocal of 2/1, I get 1/2. Okay, so that's what we're talking about when we're talking about perpendicular lines and parallel lines. Slopes are equal. The slopes product is -1. Okay, example 2, we're going to identify parallel and perpendicular lines in this diagram. It says determine which of the lines are parallel and which of the lines are perpendicular. And with looking at this, you might want to look and say, oh, the red and the green one are parallel, and the purple one's perpendicular to them, but the blue one looks like it's off a little bit. But you don't want to assume anything. What we need to do is find the slopes of all of these. So I will do it in color codes. So I'm going to find the slope of line A, which is blue. So I'm going to say the slope equals y2 minus y1 divided by x2 minus x1. Write a formula, substitute the givens. So I'm looking at my x's and my y's here. This is 1, this is 2. So y2 is 3 minus 2 divided by 0 minus a -3. Be careful, minus a negative is plus. So the slope of the blue line is 1/3. And does your answer make sense? Does it go up 1/3? And sure enough, yes, it does. And it's going up, it's positive. So the slope of the blue line is 1/3. Now I'll do the red one. We're going to use these 2 points right here. And I'm going to write m equals y2 minus y1. Why am I doing this every time? It's a form of memorization. Okay, so m equals, and then y2 is 0 minus a -1, which is +1, over 2 minus 0. So the slope of the red line is 1/2. So as you can see right now, the slope of the blue line is 1/3, and the slope of the red line is 1/2. Those two lines are not parallel, and they don't look like they are in the graph either. So they are not parallel. All right. So we can prove that by finding their slopes. If the slopes are different, they will eventually cross. All right, let's move on to the green line, which is C. I'll do that over here. M equals y2 minus y1 divided by x2 minus x1. M equals y2 is -4, y1 is -5, minus a -5 is +5. 1 minus a -1 is 1 plus 1. So the slope of the green line is -4 plus 5, which is 1, and 1 plus 1, which is 2. So now that I see that that is equal to the red slope, so right there, the red slope is equal to the green line slope, Those two lines are parallel. I will mark that in the graph. So I'll put this parallel symbol here and I'll put one on here. Red and green are in fact parallel. So now I need to find the slope of D, which is the purple line. So I'll write M equals y2 minus y1 divided by x2 minus x1. The slope therefore is, and let's make this point here. So there's no point here, no point here. They tell us this is the point -2, 0. And this point right here is the intersection of the green and the purple. And that is the point -3. I kind of wrote over it. -3, -2. So I'm using this. Let me see. I'm using this point right here, -2, 0. And I'm using -3, 2. So these are my y's. So it's y2 is 0 minus y1, which is 2, over -2 minus a -3 is +3. So the slope of the purple line is 0 minus 2, which is -2, and -2 plus 3 is 1. And that is a negative reciprocal to 1/2. So in other words, if I took the slope of 1/2, the slope of 1, if the slope of one line times the slope of a second line equals 1, then you know the lines are perpendicular. So I have the slope of the green line 1/2, the slope of the purple line -2 over 1, and when I multiply those, oops, it's -1. When I multiply those, 1 times -2 is -2, 2 times 1 is 2, and a negative times a negative, a positive. I mean, negative times positive is one, yeah. A negative divided by a positive is negative, and -2 divided by 2 is 1. So when you get a -1, when you multiply the slopes, they are in fact perpendicular. So obviously, if I put 1/2 in for the other, the red one, you're going to get the same thing. I'm not even going to do it. That's also a 1/2. So since two lines are parallel, the transversal that cuts one is perpendicular. It's got to be perpendicular to the other. So I will mark these as perpendicular. Okay, so we just answered that. Red and green are parallel. Purple is perpendicular to both the red and the green. The blue line isn't parallel or perpendicular to anybody. Okay, so now do problems 7, 8, 9, and 10 in your homework, and we'll move on. Okay, writing equations of parallel and perpendicular lines. You can apply the slope of parallel lines theorem and the slopes of perpendicular lines theorem to write equations of parallel and perpendicular lines. And we'll do just that in example 3. So here we go. So it says, write an equation of the line passing through the point -1, 1. So that's an x and a y. That is parallel to the line y equals 2x minus 3. And I just label everything up. Okay. M being slope, B being y-intercept, and I have a point. So what we have is a line y equals 2x minus 3, and we want an equation of a line that passes through this point parallel to this line. So what do we know about parallel lines? Their slopes are equal. So in my equation that I'm going to create for this example 3, we still have a slope of 2. In order for them to be parallel but not coincident or coincide, I don't want the same y-intercept, I want a different y-intercept. So all I need to do is find the y-intercept of the line that has a slope of 2 going through this point -1, 1. So you write the equation y equals mx plus b. M is going to be 2 because the slope will be equal to the line slope that they gave us. I have a y of 1, a slope of 2, an x of -1. All I need to find is the y-intercept. So this is 1 equals -2 plus b. If I add 2 to both sides, I isolate b, and I find what its value is. And in this situation, it is 3. So my equation is going to be y equals 2x plus 3. This is a line parallel to this line going through the point -1, 1. And I'm going to show you that with the graphing calculator. So let me just get that. Okay, so I'm going to put the equation y equals 2x minus 3 and graph it. Okay, so my graph was messed up from a different problem. The window was moved. So there is the graph of the line they gave us, y equals 2x minus 3. Y-intercept -3, slope of 2. They asked us to find a line parallel to it with the same slope, obviously, since it's parallel, going through the point -1, 1, and I came up with y equals 2x plus 3. So I'm going to graph that. Y equals, and I'm going to plot 2x plus 3. Graph it. And there's the line above. This is the line, the equation of the line that we came up with here. Y-intercept of 3, same slope 2, and they do look parallel. The question is the point 1, 1, I'm sorry, -1, 1 on the graph? So I'm going to trace, and I'm going to go to the other line. So here's 0, -3, and if I arrow to the left, it's going to, I'm looking for -1, 1. Okay, so there it is right there. It's pretty close, but I can't find it exactly. So I'm going to do something differently. I'm going to do a calculation. So I'm going to hit second, calculate, and I want to know a value. I want to know y when x is -1. And I hit enter. Wrong line. Let's do it again. Second, calculate, value, -1, enter, and it's putting on the same graph. Let me try something else. Let me go to y equals. Let me turn that off, and let me go back, graph it. So this is the equation of the line that we came up with. Now I want to do second, calculate a value, and I want x to be -1, enter. And there it is, y is 1. So at the point -1, 1, it is a point, a line going through that point that was parallel to our other line. Okay, this one is going to be writing an equation of a perpendicular line. Write an equation of a line passing through the point 2, 3, that is perpendicular to this line. Okay, perpendicular. And so the first thing I want to do is switch to my pen, and let's use blue this page. Okay, so we have a point, x, y. We have a line here, but it's in standard form, and I want to put it in slope-intercept form so I can see what the slope is. So I'm going to subtract 2x from both sides. I want to get it to say y equals. So y equals mx plus b. So my slope is -2, and my y-intercept is 2. So I'm just going to label that, say that. So I know my slope of the given line is -2, and my y-intercept is 2. Well, the slope of a line that is perpendicular is going to be the negative reciprocal of this slope. And since it's -2, think of that as -2 over 1. The negative of a negative is positive, and the reciprocal of 2 over 1 is 1/2. So if this sign's negative, this one has to be positive. If this is a 2, the inverse of 2 over 1 is 1/2. So I need to come up with a line that has a slope of 1/2 with points values 2, 3 on that line. So I write the equation y equals mx plus b. Substitute my givens. Y is 3, m is 1/2, x is 2, and I'm trying to find b. 3 equals 1/2 times 2, which is 1. Whoops. Plus b. To get b by itself, I need to move this 1 over to the other side by subtracting. 3 minus 1 is 2. and therefore my y-intercept is 2. So what this means is I'm going to take a line, I'm going to have a line now, y equals m plus mx plus b. So the equation of the line I want is y equals 1/2 x plus 2. Okay, so let's take a look at that in the graphing calculator. All right, let's do this. There we go. All right, so what I'm going to do, turn my calculator on, go to y equals clear and clear, and go back up. Put the original in, which is y equals negative 2x plus 2. So negative 2x plus 2. And I'm going to graph it just to take a look at it. Okay, so this is our original graph. That's the original. I want to draw a line perpendicular to it going through the point 2, 3. All right, so I'm going to go back to y equals. Go down to number 2 and put in my 1/2. 1 divide 2. I always put parentheses around fractions. X plus 2. 1/2 x plus 2. Graph it. And there's the line perpendicular. Now, one thing I want to point out to you is this doesn't look perpendicular on the screen, and it's because it's a wide screen. It's like watching a flat screen TV. It's bigger this way than it is this way, kind of like this video of me. And if I hit zoom, there's a command called square. So if I go down and hit zoom square, it's going to adjust. Where is it? There it is. Zoom square, number 5. Zoom square 5. It's going to adjust the window so it looks like it is the same wide as it is long, and therefore it looks like it is perpendicular now. And when I hit the intersection, is actually our answer, the point 0, 2, they intersected at the y-intercept. I want to know if the value of when x is 2 is y3 on our graphs. So I'm going to hit 2, enter, and I get x equals 2, y equals negative 2 on our original, but if I think I just have to arrow up, there it is, when x equals 2, y equals 3 on my perpendicular line that I came up with the equation. So this confirms that the point 2, 3 is on the line perpendicular to the original line. All right, so now at this point, you should be able to do problems 17, 18, and 20 in your homework. Okay, example 5 is finding the distance from a point to a line. It says to find the distance from the point 1, 0. Let me highlight these. So find the distance from the point 1, 0 and the line y equals negative x plus 3. I'm going to use Desmos for this. So if I go to Desmos, 1, 0 and negative x plus 3. So I'm going to plot this point 1, 0. Okay, so there's the point 1, 0. And then y equals negative x plus 3. So there is the line and there is the point. So when it says how far is this point from the line, remember they were talking about the distance from the point to the line. That would be the shortest distance, and that is the perpendicular line that goes through that point. So I need to know the slope is a negative reciprocal, and I need the point 1, 0. So it's very similar to the last 2 problems we've done. So what I need to do is, okay, this has a slope of -1, and that's -1/1. So therefore, my line that I want will have a slope of, the reciprocal of -1/1 is +1/1, or just 1. Okay, because 1 times -1 is -1, and we want our products of our slopes to equal -1 if we want perpendicular lines. Okay, so we have a line with a slope of -1. We have an x and we have a y, just like last time. 0 equals 1 times 1 plus b. 0 equals 1 plus b. Subtract 1, and I get b equals -1. Therefore, my equation is y equals, my slope m is 1, simply x minus 1. So there's the equation of the line that is going to go through that point. So if I go back to decimals and graph that to verify, go here and write y equals x minus 1. The green line obviously goes through that point. It is perpendicular to the blue line. Now we just need to find the distance between this point and that point right there. Okay. So, and we could have done that using the graph, but if we weren't graphing it, I was just verifying with the graph what is happening here. Now we have two equations, y equals x minus 1 and y equals -x plus 3. So if I have y equals x minus 1 and y equals -x plus 3, and I want to know where they intersect, then I'm going to set them equal to each other. Where the two lines are equal is where they cross. So I'm going to say x minus 1. It's also substituting it in. If y equals x minus 1 and there's a y here, I can put what y is equal to in place of y. And that's x minus 1 equals -x plus 3. Okay, all your x's on one side, you want them positive, so I'm going to add an x to both sides. And I get 2x minus 1 equals 3. I want to get rid of this 1. Okay, and that is going to give me 2x equals 4. Divide both sides by 2, and I get x equals 2. Okay, now the book shows us doing that two different ways. I found x equals 2. Well, if I put 2 in here, 2 minus 1 is 1. And if I put 2 in here, -2 plus 3 is 1. In both of those substitutions, I get y equals 1. I'll show that. Y equals my x I just found minus 1. Y equals 1. Put it in the other one. Y equals -2 plus 3. Y equals -1. No, it does not. Just kidding. -2 plus 3 is not -1. -2 plus 3 is 1. Okay, so it comes out to be 2, 1. So the point, so it says find the distance from the point 1, 0 and this line. Well, it's the point of intersection, and we just got the point of intersection to be x. X is 2 and y is 1. So I have the point 2, 1, and I have the point 1, 0. Distance formula is the square root of x2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So I substitute in my givens. X2 minus x1. 1. Y2 minus y1. So d equals the square root of 2 minus 1, which is 1 squared, plus 1 minus 0, which is 1 squared. So d equals the square root of 1 plus 1, which is 2. So the distance between those 2 points is the square root of 2. And the square root of 2, which is approximately, hey Siri, what's the square root of 2?
The square root of 2 is approximately 1.4142.
Okay, so I'll go out 4 decimal places, and the distance between those 2 points is 1.4142, or the square root of 2. Okay, so I'm going to show that in the graph again. So from here to here is 1.4112, or the square root of 2. Okay, so now after doing that, well, went back to example 4. Okay, so let's recap this. A lot happened there. So we had an x, we had a y, we knew a slope. Find the distance from a point to a line. You need the negative reciprocal because the line that the other point is on to be perpendicular. The distance between a point and a line, the shortest distance is its perpendicular segment. I need to find the line value or line equation of that perpendicular. So the slope is the negative reciprocal, and you find your y-intercept and you get the equation of your line. Set those two equations equal and solve for x. Substitute x into the equation to find y. Do the distance formula with your original point and the point on your perpendicular line where they intersect, and you get the distance. Okay, so now try 21, 22, and 24. Okay, that brings us to the end of chapter 3.5. So now do the exercises if you haven't already, which you should have because I asked you to do them after every example. But anyhow, there they are. Have a great day.